In the last video, we ingested enterprise knowledge into the system. Documents were cleaned, chunked, enriched with metadata, converted into embeddings, and stored. The knowledge base is now ready. Now we can answer the question we have been building toward. What actually happens when a user asks something? This is where retrieval begins. Now, we do not send the user's question directly to the model. The request moves through a controlled pipeline of decisions. Every stage has a specific responsibility. Classify the request, identify the caller, retrieve candidate evidence, enforce access rules, remove invalid content, prioritize the strongest results, validate relevance, assemble context, generate an answer, and verify citation traceability. Now, the first stage is classification. Before any search happens, the system determines whether the request is a legitimate policy question or a request that should be straightaway refused. This is the first safety gate. If the request passes classification, the system builds an access context for the caller. That context captures who the caller is, which scopes they hold, and whether they have administrative access. Let me make that concrete. Imagine that a user has read access and asks a policy question. The search may find semantically relevant chunk, but that chunk may require a scope that user does not have. In that case, the chunk is removed before it can reach the model. Administrative access can bypass scope restrictions, but for normal users, the access context travels through the entire retrieval pipeline. In a banking system, retrieval is not about finding relevant information, it is also about ensuring that the right person is allowed to see that information. Once the access context is available, the hybrid search begins. Vector search finds chunks that are semantically related to the question, and keyword search finds chunks that are or that contain direct term overlap. The system combines the results from both retrieval methods and calculates a hybrid score. Vector search gives us a semantic recall. Keyword search gives us precision for explicit terms. Together, they create a stronger candidate set than either method alone. We will examine the hybrid search implementation in the next video. The retrieved candidate then passes through two governance filters. The permission filter removes any chunk the caller is not authorized to access based on scope and sensitivity metadata. The validity filter removes content that is not currently effective. This can include expired policies, future dated policies, or content whose effective date metadata does not make it valid for the current request. After these filters, the remaining candidates are both authorized and current. The surviving chunks are then re-ranked. The re-ranker uses the hybrid retrieval score together with lightweight query term overlap to prioritize the strongest candidates. This stage does not generate an answer. It only improves the ordering of the available evidence. Next comes the relevance gate. This is an important boundary. Vector search is designed to return the closest available candidates even when none of them truly answers the question. The relevance gate prevents a weak retrieval result from automatically becoming model context. If the highest ranked result does not meet the configured minimum score, the pipeline stops and returns. No relevant policy found in available documents is what we show to the user. So retrieval candidates are not automatically treated as evidence. They must first demonstrate sufficient relevance. If the results pass the relevance gate, context assembly begins. Context assembly selects the highest ranked chunks, removes duplicates, respects the configured token and character budgets, and prepares the final evidence package for the model. This stage must preserve enough of each selected chunk to retain the actual policy rule. If a chunk is truncated too aggressively, the exact sentence needed to answer the question may be lost. That is why context limits must be tuned carefully. The assembled context is then inserted into a CTIDR structured prompt. The prompt defines the role, context, task, instructions, retrieve data, and response format. It tells the model to use only the retrieved evidence, avoid unsupported claims, keep the answer concise, and include citation markers. The model then generates the answer. After generation, the citation verifier checks that the answer contains citation markers and that those marker points to sources included in the assembled context. This verification is intentionally lightweight. It confirms citation traceability, but it does not independently prove that every cited source semantically supports every generated claim. A production grade system may add claim to source validation, but that introduces another scoring and evaluation layer. We are not doing that in this course. Only after these stages does the application return the final answer. In a simple RAG prototype, it can be tempting to retrieve a few chunks, place them into a prompt, and immediately generate a response. But BankStack takes a more controlled approach. Retrieved text is not automatically treated as trusted evidence. Before it reaches the model, evidence must be authorized, currently valid, sufficiently relevant, assembled within controlled limits, and traceable through citations. That is what makes this pipeline policy aware. Now, if this feels like a lot, that is completely normal. This video gives you the complete map. Starting in the next video, we will go through the implementation stage by stage. Hybrid search, permission filtering, validity filtering, re-ranking, the relevance gate, context assembly, prompt construction, and citation verification. The diagram is the map. The next videos are the territory. And I'll see you there.